The last part of today's lesson is going to be focused on operations with polynomials. First, we need to know what a polynomial is. Polynomial is an expression with two or more terms. When you have an expression that has one term, we call it a monomial. Okay, so monomial is one, polynomial is two or more. And in order to classify as a polynomial, each of your terms has to have positive integer exponents. So you can't have any negative exponents or any exponents that are fractions. So you want to make sure you're looking for those exponents. Okay, so some examples of polynomials are here below. We've got 2x plus 6x to the fifth minus 7. Notice that all of those exponents are positive whole numbers. In this middle example, even though we have got tons of different variables, they're all positive whole exponents, so this would be a polynomial. And then something simple like 2x minus 6, this would also be a polynomial. The examples that are not polynomials would be like the ones below. We've got x to the negative 3, y z squared plus 3x. The negative 3 exponent automatically makes it so that it is not a polynomial. And then in this example here, we have the square root of x plus 5y. And even though that looks like it would be a polynomial, the square root of something is the same as having that number or that variable to the 1/2 power. So a square root is the same as a 1/2. So this is not a polynomial because that has a fraction as an exponent. Okay, so if you ever see any of those things, that's a red flag that it's not considered a polynomial. Now, the degree of a polynomial is found by looking for the term with the highest exponent combined. So, excuse me, if I have these two examples here, what I would want to do is first make sure they're polynomials and then figure out their degree. In 5x to the third minus 7, all positive exponents, no fractions, so we know it's a polynomial, and we then have to look for the highest exponent, which is a 3. So we would say that the degree is 3. Okay. In the next one, in this polynomial, all positive integers for our exponents, so this again is a polynomial, but when I look for my exponent, I have to look at each term. So in the first term, my degree is 7, okay, because 1 plus 6 is 7. In the second one, I've got 9 for my highest exponent. And the third one, when I add my exponents together, it's 10. And then the very last one, my exponent is a 1. So when I look at each of my individual terms, my degree for this polynomial is actually going to be 10. Even though it doesn't look like it's the highest exponent, together this one term has the highest degree. So always look for the highest. If there's multiple variables, you want to make sure you add those exponents together, and that'll tell you what your total degree is for each term. The last thing we're going to do is use these polynomials to add, subtract, and multiply. In the next lesson, we're going to be focusing on the division, so for now we're just going to do these three. And I basically just have an example of each, and then you'll be good to go. So in the first example, we're just going to be subtracting two polynomials. When you are subtracting or adding polynomials, it's basically just combining like terms. The key is just making sure you're careful with your positives and your negatives. So in this first example, we're going to go ahead and combine like terms. So we've got x squared and an x squared. So if I subtract x squared minus 3x squared, we get negative 2x squared. The next part would be negative 5x minus positive 1x. That would be negative 6x. And then lastly, 2 minus negative 1. That's going to get us a positive 3 because we have a minus and a minus, which we know becomes a positive. Sometimes subtraction causes people a lot of issues, so my suggestion would be make sure you're subtracting every single item in the second polynomial, or if it's easier for you, go ahead and distribute the negative all the way through and then just add everything together. Whatever you think was going to be the easiest in terms of making sure you have the correct signs and you're adding the right numbers together. In the last example, we're going to be multiplying two polynomials together. So you basically just want to think of foiling or distributing, however you think of it, and you want to make sure you multiply every single piece together. Now when you do multiply polynomials, you have to think about your exponent rules. Remember, when we multiply similar bases together, that means we add our exponents. So I'm going to go ahead and FOIL this one. So the first two terms together, 2 times 4 is 8, and a times a to the third is a to the fourth, and then we have b. Then I'm going to go ahead and multiply the last. So 2a times 5 is 10a. Then I'm going to go ahead and multiply the inside terms. Negative 6b squared times 4a cubed b. Negative 6 times 4 would be negative 24. Then we have an a cubed, and then b squared, and b would be b to the fourth. And then lastly, we have the last two, which would be negative 6b squared times 5. So that's going to give us negative 30b squared. So notice I multiplied every single part together, every single term, and then I raised the exponents if necessary. Okay. So I would like you guys to go ahead and try this example here. This one's just distributing, so you're going to make sure you multiply each term by the 3x squared, making sure that any of them that have x's, you add the exponents together. And if you would like me to check that in class, please let me know. But that's it for today's lesson. Thanks for listening.